Hello friends, let's discuss one step ahead over classical EOQ model. Classical EOQ model means classical economic order quantity models. Already I have prepared a video on these particular models, but there are some loopholes in classical EOQ model. In that model, whatever the assumption has been taken in the context of demand, quantity, productions, lead time, all are remain constant. That was the assumption in the classical EOQ model. But in the real time scenario, when you are dealing with production system, then the demand for quantity, demand for productions, demand for use of the inventory always be not constant. It will be changed as per the production need. So the particular model is highlighted about how in the time of production, the production rate of inventories and use of the inventory has been changed, and what should be the new rule of the model establishment through this production order quantity model has been discussed in the following video. Looking into that context, two important assumptions I have taken, or the model has been taken for more discussion. The one assumption is that the model is applicable when inventory continuously flow over a period of time. It means daily production rate will change, daily consumption rate of the inventory will be changed, and simultaneously whatever has been left out in daily basis, that will be piling up in a regular manner, and certain point of the time you will get your average quantity of inventories for calculation of the setup cost and the holding cost. That should be the prima facie to establish the particular model. The second assumption is that here we take into account the daily production and daily demand rate. That is the most important rate, daily production and daily demand rate of inventory. That is the new rules of production order quantity models mainly observed in the production operations scenarios during the production of product and services. Let's discuss how it has been developed. The same thing in the left side, you just see the all type of the equational abbreviations. That is the Q equal to number of pieces per order. Q symbolic, you can say the star mark of the Q, that is the optimal quantity you have to order to justify your production order quantity model. D equal to annual demand in units for the inventory items. S equal to setup cost, H equal to holding cost, P equal to daily production rate, small d equal to daily demand rate, and T length of the production run in a day. In that way it has been established. You all know that what should be the annual setup cost? It's the number of orders placed per year into setup cost. Number of orders placed per year. How you can calculate? That is annual demand, whatever your annual demand, divided by number of units in each order. That is DS by Q. If you calculate, then D equal to demand, annual demand, S equal to setup cost, and Q equal to you can say that the quantity you have to order in a particular time period. Similarly, annual holding cost. How you can calculate annual holding cost? Already highlighted in my previous video. That is average inventory level into holding cost. And average inventory level equal to maximum inventory level divided by 2 into H. But here maximum inventory level is not same like that is Q by 2 into H. Here the Q is bit different because it depends on the you can say that daily production rate and daily consumption rate of the inventories. So you should know that what should be the daily production rate and daily consumption rate. In this way you have to calculate. So maximum inventory level equal to total produced during the production run minus total used in the production run. The total produced in the production run, suppose per hour it is PT, or you can say that per hour equal to P, the total run equal to, suppose just for the T hour, that is the PT. D equal to the total, you can say the total consumption or total used in the production run, D into T, the DT, the PT minus DT equal to maximum inventory level. But the thing is that what is Q? Q equal to PT. P means per hour you are producing this or you are using this quantity of the inventories, and T equal to numbers of hour, then you can understand that what should be the Q. And if you sum up, you can say that you convert everything in the line of T, the T equal to Q by P. I substitute T in the equations, that is PT minus DT equations, then equal to, it is Q whole into 1 minus D by P. If I put Q into 1 minus D by P in the holding cost or annual inventory holding cost, that is Q by T into 1 minus D by P into H, that is equation number 2. And you all know that the optimal economic order quantity, to understand the, you can say that Q star, then it should be 2ds divided by H into 1 minus D by P whole root over. Or how it has been calculated? It just equalize the equation number 1 and equation number 2. Equalize the setup cost with the holding cost. In this way, you can calculate the production order quantity models or optimum number of pieces per order or inventory to maintain a optimized cost scenario to make your systems more efficient one. Just I highlighted that the model you will not find you can say that Andy Vora books. You have to follow other books. But the thing is that you just write in your notebook, just go through in detail, because in my course curriculum days, the production order quantity models has not been taken into consideration. We are always be used to classical UQ model. But now in BASMA course, you will find this is the one you have to go through. You just write the equations in your notebook, understand the things. If any times you will find difficulties, write in the chat box and our students discuss the same in the classroom. And through these practices only you have to control the concept. Other than that, it's very difficult for all of you to mug up the things in the mind and use in the examination purpose. Do practice, practice and practice. That helps you to be a very good manager in agribusiness domain. Thank you all. Thank you for watching my video.